So our topic at hand today is going to be Evap system diagnosis. It's been a little while since we talked about it. Well, it's been about 6 weeks since I talked about it the first time, but before that, it's been a little while. So we're going to talk through, kind of review how the system works and all that, and then we'll get through. We're going to talk about some more modern implementations that have been put into Evap systems lately. So let's just get to it. So Evap components, the main components anyways, that we're going to talk about. I'm sure there's some outliers out there that aren't used on every vehicle, but you have a purge solenoid, you have your vent valve, you have the actual canister itself that holds the vapors, fuel tank pressure sensor, and there may be pumps and other associated modules like the NVLD, eSIM, DMTL, depending on the manufacturer, what they want to call it. A lot of abbreviations, but we'll talk through a couple of those in a little bit when we work through this presentation. So how does it work? Let's do a quick review on how an Evap system works. We got this fancy animation we've had for a while. Might as well use it. So we have our purge solenoid, which is up here. We're going to have our vent valve, which is down here. And we're going to have our fuel tank pressure sensor, which is there. And this is the canister over here. And this, of course, the fuel tank, engine, PCM. So it's all electronically controlled. And what the Evap system does, of course, is it captures that evaporative vapor when I fill the fuel tank. So default state is going to be the purge valve is going to be closed, and the vent valve, which is the back door, that's going to be open. It allows fresh air to escape because the fuel is going to displace the air that's in there. So we're going to load fuel in. As the fuel loads in, it's going to, of course, make vapors. Vapors are going to go up into the canister and displace the air that's in there out the back, right? So that's it's how it captures it. Then once that happens, engine's going to run, engine's going to warm up. Then once it gets to a set point where it can purge, the computer is going to send a command to the purge valve. It's going to open it up to the vacuum of the engine. That's going to suck in fresh air to displace the vapors that are in there. And then that gets run into the engine and reburned. Now, as it's drawing a vacuum, after a certain amount of time, whatever the PCM determines, it is going to then close the vent valve while leaving the purge valve open. Now, when that happens, it is going to draw a vacuum on the fuel tank and the fuel system. So this is how we're going to check for leaks. So it's going to draw a vacuum, and then it's going to close the purge valve. And then now it is drawing a vacuum. Time is going to start. Computer is going to measure how fast, if at all, does this vacuum decay. If the vacuum does not decay like we have here, no leak. Now, in the real world, I'm sure it's going to decay at least a little bit because usually there's at least a teeny tiny bit of a leak in there. It's not enough to set a code, but usually there's a little bit of a leak. And then if it does decay quickly, then I know I have a larger leak. If it decays slowly, then I know I have a smaller leak. And the computer can judge based on how long that vacuum takes to decay, how big the leak is. So if it's over a certain threshold, depending on the year of the car, it's 40 thousandths pre-2000, 20 thousandths post-2000, and now we have quite a few vehicles out there where it's 10 thousandths of a leak. There's also some vehicles out there like my Subaru that is PZEV. I don't know if you've ever seen that logo before, but PZEV is partial zero emissions vehicle. And the zero part of the emissions in that case is actually the Evap system. So it lets no Evap emissions out into the atmosphere. So I guess it just does a good job of capturing it. Anyways, probably marketing. And this vehicle definitely needs a fan. All right, so let's look at a more modern system, right? So that's a basic textbook system we just looked at with animations. Here's a more modern vehicle. Now, I picked this vehicle for two reasons. One, because it's got some interesting stuff in it, other things that you might not necessarily think about. And two, it's excellent pictures from the manufacturer. And I will say that is pretty few and far between that get a really nice picture from the OEM that shows exactly how everything's laid out and everything. So this is the Evap system on a Jeep Grand Wagoneer with the turbo motor, the 3-liter turbo motor. So we, of course, have our fuel tank in here with some check valves. We have the charcoal canister, the eSIM, which is the Evap system integrity monitor. Also has a filter out the vent now. So instead of just having the regular vent, it has a filter out there to lessen the Evap emissions, I guess. Fuel vapor goes into the purge solenoid. The purge solenoid also has check valves in there because this has a turbocharger on it. And if I am in boosts, it cannot purge on the boost side because it's on the boosted side of the turbo, because it's not going to be able to get in there because it works on vacuum, remember? So it's going to have boost, so it's not going to be able to purge there. So instead, when it does sense boost over there, it then purges this way, oops, in through this ejector T, which we're going to take a better look at in a little bit, in through the air box and then back through the turbo that way, because that'll still be drawing a vacuum on that side of the turbo, but it won't be drawing vacuum on that side. Then, of course, when I have vacuum, I'm going to purge just my normal way through the intake manifold like I would on a regular car. Also, a couple of check valves in there, just in case. And then this OBD vent valve, which is for testing, computer testing purposes, which is in there as well. So here's just a closer look at the purge solenoid. It's got a check valve in here in this side. So this side goes out to the air filter compartment, and then this side would go to the engine, depending on whether it's in boost or vacuum. So it just kind of helps it switch as to whether or not it's in boost or vacuum. To see that a little better, we have a little block diagram. So it's going to come from the canister through the purge solenoid into the intake manifold, just like it normally would if it's under naturally aspirated or non-boost conditions. Then under boost, instead of allowing it to go that way, we're going to have a check valve here, which is going to close because it'll be under pressure, right? So it's going to push it that way. It's going to close that. And then it'll open this check valve here and allow it to go back through that T, through the air box, and then back into the intake manifold that way. So it just depends on what condition the vehicle is. Is it under vacuum or is it under boost? Now, multiple other manufacturers have turbochargers, and they use similar type systems to this. Like I said, this is they did a really good job. I will give it to Chrysler on this one. I don't usually give them much credit, but in this case, they have excellent pictures that I can use to show you how it works. Here's an example of that check valve on the air cleaner. So if it's got boost air, pushes it down. Purge air is going to go through here as well, and allows it out to the air box. The eSIM is the evaporative system integrity monitor. So it runs with two weights in there. One's for measuring vacuum and one's for pressure. And then it has a little diaphragm in there as well and a little switch in there. So there's a really good description of how this works in the guided component test. So we'll talk about that when we go live on the tool so we can read through it there. And then the canister, it's kind of an interesting looking canister, I would say, compared to most others. Just kind of look like a box. This one looks like a couple cylinders, I guess. And then there's that eSIM we just looked at. There's some inlet and outlet. And then there's that filter we were talking about earlier too. So there's actually a filter in there. Also, a little unique on this vehicle is the fuel tank pressure sensor is not on the fuel tank. In this case, it is by the filler neck, and it's kind of up a little higher. It's in the wheel well. So what they say, Chrysler, Stellantis, whatever, what they say is that they do that in case it's going to be going off road under deeper water or anything, so it doesn't get water intrusion into it. Okay. I don't know if I'm going to be taking my starts at $100,000 gigantic SUV off road, but maybe some people would. Okay, I guess. So that's their justification behind it, anyways. Instead of putting it down a little bit lower, they put it up a little bit higher, and that's what they say it's due to if you're going to cross like a river or something like that. And then the vent blocker valve is going to be in there, so that kind of separates the two sides of the system from the tank and then the canister. So it kind of separates, so it's able to measure on either side of that and see where the problem may be. which brings me to codes. When we're diagnosing Evap codes, there's two different types of Evap codes that could possibly come up. Be very aware of what your code says. What is the definition of the code? And if you don't happen to have it on the scan tool for some reason, I would look it up, because you could be fighting, oh man, it just says evap, so it must be a leak, right? However, these sampling of codes over here could be the purge control solenoid, vent controls, pressure sensor, another purge solenoid code there. So it could be an electrical problem and you're chasing a leak problem. Vice versa, I guess it'd probably be less common as you're chasing an electrical problem when really it's a leak that you're trying to find. And to be fair, if you have a problem with one of these valves, they're not closing all the way, because of an electrical problem, it could also be giving you a leak. So to be fair, you might get a combination of electrical and leak codes, but that just rings very true in my mind because of just a situation that I had a couple years, a while ago, probably about 5-6 years ago. But I had somebody call me and say, "Hey, I've been chasing this evap problem for a month, and I replaced a ton of stuff. Can you come take a look?" And it ended up being it was the purge valve. I think it was a 443 actually. So it was a problem with the purge solenoid, and we replaced the purge solenoid. Everything, the code went away, and it was fine. But this person chased that leak that wasn't actually there for a month, and it kept coming back. So as you can imagine, the customer wasn't terribly pleased. But always read the code definition is the moral of that story. If it's an electrical problem, obviously we check it electrically, and we'll talk more about that in a little bit. If it's a leak problem, then you probably want to use an evap machine, smoke machine, that sort of thing. Can be very invaluable trying to chase down a leak, because you put the smoke in, it should come out wherever there's a leak. So this is the example of the new smoke machine that we just came out with, ELD 700A. So it replaces all the previous ones we have. It's got a bunch of interesting features that I'm not going to necessarily get into here, but it does have some unique stuff in there, like a air only test, and then put vapor in, backlit flow meter and stuff like that. So talk to your Snap-on representative if you're interested. Most vehicles are going to have a port under the hood. I say most, but a large number of vehicles will have the port under the hood. If they don't have the port under the hood, you just want to find a tap into one of the evap lines somewhere. But in this case, we have a Schrader valve in there, and it is a lefty-tighty, righty-loosey situation, so it is a reverse thread, so just be aware of that when you're pulling the Schrader valve, because you have to pull the Schrader valve out in order to put the smoke in, right? And just put the smoke in, see where it comes out, see if you can find it. Could be in the tank too, so there's ways to smoke in the tank. Here's an example of a leaking vent valve. That needs to get fixed first before we can do anything, because that's the first thing we need to do, is close the system when we put smoke into it, right? So you would go in under your scan tool, find the bidirectional control to close that vent valve, and then you put the smoke in. So if it's leaking, got to fix that first. Here's another example of a leak. This was a sending unit, and it was at a school, and they cross-threaded it. Didn't realize they cross-threaded it. Came up with an evap problem, and sure enough, there's the smoke coming out of that sending unit. Here's another example. I mean, this hose looks like garbage anyways, but you can see where it's definitely just pouring smoke out of that crack right there, right? So obviously that's a problem. That's a leak. So leak testing is fairly straightforward as long as you got a smoke machine. Electrical testing can be a little less straightforward, but still fairly simplified if we use, say, a guided component test. If we have a Snap-on scan tool with a scope meter, then you will have access to 8 million plus guided component tests within the tool. It goes back to 1981. So you'll be able to cover pretty much any evap on any vehicle that you would need to cover. So in this example, this is on a Toyota Camry, and it's talking about the evap purge solenoid. Component information on that's 12 volts and ground. So I'm going to walk you through a couple different ways to test it. Makes it simple. Sets it up for you. Tells you where to plug it in. Oftentimes now we even have images of what it would look like on the vehicle. So all good stuff. So let's talk about some of that good stuff. Let's go live on the tool. All right, first one I want to pull up is that Grand Wagoneer. And speaking of guided component tests, We do have some guided component tests in here. This is that new 3-liter, like I said. And I can go into the Evap system there. And you can see we have the eSIM, fuel tank isolation valve we talked about, fuel tank pressure sensor, OBD vent valve, and the purge solenoid. So the eSIM, we go into information. It's the evaporative system integrity monitor. It's very similar to the NVLD, which is natural vacuum leak detection, which is what they used at Chrysler previously. Although it does not require a solenoid. The eSIM mounts directly to the canister. It consists of a housing, a small weight, and a large weight that serve as check valves, a diaphragm, a switch, and a cover. There's a check valve for each of the weights in the eSIM assembly with a seal attached at the end of each weighted check valve. Large weight check valve seals for pressure. Small weight check valve seals for vacuum. After the vehicle is shut down, the fuel system is sealed. As it cools, the internal pressure will drop. If the pressure drops enough to close the switch, the small leak test is passed. Right, so it was able to pull enough vacuum on there. When the pressure decayed into vacuum, then it closes the switch and it passes. The small leak test does not run. The PCM will run medium and large leak test on startup. Using engine vacuum, the fuel system will be drawn in a vacuum to test its integrity. So it doesn't work one way, it'll work another way. And then it gives us our pinouts there. And then if we go into the switch test, it's going to show you how to hook it up to the tool, hook it up to the car, hook it up to the unit. Fuel level should be 85% or less than fuel system, the longer it'll take to close the switch. Back row for voltage at the switch sense, which would be the eSIM signal right there. Black to no good ground. Remove the fuel filler cap to release any vacuum. Key off voltage should be 5 volts. Locate the purge solenoid. Connect the hand vacuum pump to the vacuum line from the canister. We mark CAN or check for which one does not have the engine vacuum when engine running. Reinstall the filler cap, put vacuum in the system while monitoring voltage at approximately 1 inch mercury. Switch should close and voltage to 0 volts. Relieve the vacuum, voltage should go to 5 volts. So it's a simple on-off switch. You're either going to see 5 volts or no volts. If you see anything other than that, or anything not close to 5 volts, then probably need to inspect that switch. Fuel tank isolation valve. So normally closed fuel tank isolation valve located between the fuel tank and the charcoal canister is used to manage pressure and vacuum in the fuel tank. When the isolation valve is closed, it splits the evap system into 2 separate diagnosable sections during leak testing, fresh air side and the fuel tank side. During normal engine operation, it is mechanically open to relieve excess fuel tank pressure above approximately 4.64 psi and excess vacuum below approximately -2 psi. When refueling, the fuel door release is pressed, the fuel tank pressure sensor input is received. Fuel tank isolation valve is energized open by the PCM, and the tank pressure is relieved by controlled rate. When the pressure is reduced below a calibrated threshold, the fuel door is unlocked and refueling can begin. Fuel tank isolation valve is de-energized after the fuel door is closed. So it's even switched by the fuel door itself when we're fueling the vehicle. Interesting. So there's a voltage test on that one. Fuel tank pressure sensor is going to give you a voltage test. And it's going to be key on engine off should be 5 volts. If not, test for open shorts or resistance problems. And so on and so forth. 0.5 volt to 4.5 volts depending on tank pressure. There we go. OBD vent valve. It's in series with the purge valve. The OBD valve needs to be turned on to allow vapors to get to the purge valve and open the eSIM switch for diagnostics. Power is from the ASD relay and ground is controlled by the PCM. So it's power and ground. Simple enough. And then purge solenoid. Normally closed solenoid used to purge fuel vapors in the evap canister. We already know that. Purge back in the intake manifold that burned again in the combustion chambers. It's going to give us a power and ground in there. All right. And then if we go into shop key. And we just look up evap system. And we can go into, there's TSB on that too. YTech small leak verification tests for 456. 2012 to 2023. It's a test for a PO456 for a small leak test. Information only. There is a PCM software update apparently. Actually, that's what I was going to talk about in there. Must be run first to verify the leak is present. Run after repairing, replacing any components to verify the fix. This includes PCM software updates to correct those concerns. So road test will not confirm repair. 456 is only set with multiple engine off and drive cycles. It cannot be reproduced during a dealer visit. It's the only tool currently available to confirm a fix after repair and ensure the vehicle is fixed the first visit. Fix the first visit. That's important. Small leak verification test. And then OEM testing on the Evap system. So there's that beautiful diagram picture that we had before. Looks nice. Let's see what else we got. Should have some other pictures in here. Component operation. There we go. There's some components. There's where the canister is. There's some other vent valve and stuff. There's that purge flow diagram, ejector T diagrams, eSIM, fuel tank pressure sensor, internal tank valves. It's got 3 tank valves, a tank vent valve, grade vent valve, and fuel filler check valve. A couple block diagrams. There's a purge valve. And then there's that vent blocker valve, right? So a lot of good information in here, and wiring diagrams as well. Engine, it'll be under the entire engine control circuit there. So fuel tank pressure sensor in the fuel filler pipe. So a bunch of different things there can be had. So good stuff. Next one is going to be the Cadillac CT4. So this one actually has a new test that's been added on the scan tool side of things under engine. And we go to functional tests. And there's our Evap service bay test. That's been in there for a while. So that is a GM specific tests that's in there that forces the Evap monitor while it's in the bay. Importantly for this, by the way, since we're talking about it, there are, for the service information, familiarize yourself with conditions for running this test. You need to meet all the conditions to run the test. It's going to be 3 stages: engine idling, drive cycle, and ignition off. Verify the test monitor is not already completed. Do not start the engine, set ignition on or run. Transmission in park or neutral. Follow data parameter Evap test state on the test screen and know when the vehicle is ready for drive cycle ignition off. So on the data display screen, start the engine and let it idle. So it's going to go in there and it's going to pull up this. And then you want to look at the test status. So in this case, it's waiting for purge to enable. You would hit complete and then would cycle it through to the next state after it's in the proper state. In this case, I'm in a simulator, doesn't let me do it. And then there's also the Evap emissions canister purge valve leak test. This is a little bit different than the on-off test that you might have with a bidirectional control. So you can set it to not venting, which is closed, venting, which is open, and release control of the module itself. So if we wanted to set it to not venting, it's going to go through and it's going to count down 30 seconds. It's going to close it for 30 seconds. And then you're able to test and check for vacuum decay. So in this case, I'm going to exit because I don't need to wait that time, but that's pretty much what it does. It closes it or opens it for 30 seconds. Nothing really fancy, but it's in the factory tool, and it's now in the Snap-on tool. Next one is a Ford Focus. So Ford does some slightly unique things with their Evap as well. All Evaps found in the engine, of course. Functional test, special functions. We have a gross leak test, which is for a large leak. Small leak test, which is for a small leak. And then we have a cold soak time bypass. That's important if you want to test and want to force the monitor, but there's a cold soak for the amount of time you have to wait for the vehicle to cool off. And you can bypass that. This procedure will erase freeze frame data, reset OBD monitors, clear engine and transmission codes. Bypass Evap cold soak time. Key must be on with engine running. And then it's going to go through. Do not cycle the ignition key. It is bypassed, ready to perform the Evap readiness monitor, and then it would go through and do the monitor. In that case, you would need to take the drive cycle in order to go through the monitor. Also got a component test in here. So if I go into engine, you can see under Evap, component information on the whole Evap system. It's going to give you multiple solenoid descriptions, vapor blocking valve, fuel tank pressure sensor. It's going to give you the information on that. Purge solenoid, same deal. Going to give you some tests to do, resistance signature test. And the vent solenoid as well, resistance test and voltage test and component information. So a lot of good information there. We're also going to pull up this RAM, which does stuff a little bit different as well. So it's going to be similar to the Cherokee, or Wagoneer, sorry. Grand Wagoneer. I think it's under miscellaneous functions. Yeah, so there's that small leak verification test that they were talking about with the Wagoneer. I didn't go in and show you, but there's your PCM small leak verification test. So after you're done diagnosing a 4056, you need to go in here and do that small leak verification test. Perform any service bulletins or flash updates related to Evap fault codes before proceeding. Remember how it said there was a flash update for a 456? Uses pressure over time to detect a leak. There are 5 possible test phases. To get it passed in test phase 2, the Evap system will need to be either heating up or cooling down. You got to do it while it's warming up or cooling off. There's a possible leak in the system is very stable. Second intrusive part of the test 4 and 5 will run. Must not be running. It's going to think it's running because it's in sim mode. So it's not going to let me go any further, but that's okay. So there's that verification test that they mentioned before. And then there should be guided component tests on this one as well. Evap system. So eSIM unit. So that's going to be very similar to what we talked about earlier. Switch test, fuel tank pressure sensor, and purge solenoid. It's going to have a couple tests there. So a lot of good information to be had if you have a Snap-on tool. It's all readily available in the guided component test if you need a refresher on how it works. Actually, inside the guided component test as well, if I back out of the vehicle, we have the classes there. So there should be a couple things on Evap in here as well. Force induction, relay test, spark ignition test. All right, so there's a lot of good information in there. Should be some Evap related things in there as well. So that is Evap. Hopefully you learned a little bit about diagnosing the system, how the system works, different components on different types of vehicles now, especially if they're turbocharged. I know Honda has a similar type check valve system going on and on their turbocharged vehicles. So definitely something to keep a lookout for. Let's talk about what we're going to talk about next week. So next week we are starting on all new classes again. So we'll be running brand new classes all the way through kind of mid-January, I guess. And then we'll repeat them again. And then there's going to be some changes next year. You will see some changes probably around March-ish. So it's just be a little different format. Might be a little bit different time as well. We'll be kind of looking at the different times where we're actually going to go live. And it'll be maybe down to 1 time a night. But we're taking a look at all that just so you're aware. There are some changes coming down the pike. But it won't be till probably February, March. So we'll give you plenty of warning. But next new class is going to be continuing our OEM specific ADAS training that we've been doing this year, and next week's subject is Volvo. So we're going to talk about how their ADAS systems work, and they seem fairly easy to calibrate. So join me as always every Tuesday 6 and 9 Eastern. If you want to join on Zoom, go to snapon.com/OT to join me there. Otherwise, the 6 p.m. Eastern class goes live to our YouTube channel, so it's youtube.com/Snap-on Diagnostics. You can scan that QR code to bring you there and automatically subscribe you for that. 9 p.m. Eastern class goes live to our Facebook page. So it is Facebook, and it is Snap-on Diagnostics Product and Training is what it's called now. So check it out there at 9 p.m. Eastern if you're on Facebook. If you want to see any of the other episodes in this series, anywhere from Intro to ADAS to this Evap System Diagnosis class, this is episode 126. So we have at least 126 episodes in there on a playlist. For live training, and they're all roughly half hour, 40 minutes long. So by my math, that's a lot of time, 60 plus hours worth of training. So, and it's all free. So make sure you go to youtube.com/Snap-on Diagnostics to check them out. Also, do we have your email address? If we don't have your email address, you may be missing out on some important stuff like technical focus articles, SureTrek blogs, quick tips, new product releases. We released 2 new products this year. They released my schedule. They put on my schedule periodically. So if you do not receive those types of emails, you can scan that QR code right there. It brings you to a form, fill out your particulars, and that will get you started on this email journey. Here's an example of a Tech Focus article on diagnosing a timing chain. Here's a SureTrack blog example on a P0449. Hey, I think that's an Evap code. What do you know? So if you're not receiving those valuable content and you want to, scan that QR code and that'll get you there. All right, time for questions. If you do have a question on Zoom, please make sure that you have wow, can't talk tonight. Hit the Q&A button, type in your question. I'll get to those momentarily. If you're on the YouTubes, make sure that you check that out as well. You can use the live chat on YouTube. So let's see, we got one on the Jay saying thanks for the class once again. You're very welcome, sir. Thank you for joining as always. I see a couple of familiar names on there. We got Anthony on here as well. So welcome there. And then on the YouTube, thank you again for all the valuable information. Really appreciate all the help. Heavy equipment tech, but it's always nice to be informed on the lighter applications for sure. So thanks for that, Nick, on YouTube. Glad you find this useful. And if you do find it useful, make sure you tell your friends, right? Because free training, never a bad thing. So with that, looks like we've cleared the board. So thank you very much for taking a little bit of time out of your day to learn a little bit more out of Evap. Hopefully you'll join me next week for Volvo ADAS. With that, enjoy the rest of your week. Enjoy your weekend. Have a nice night and take care.